Welcome to This Explainer. Today, we're diving deep into the bizarre so we can actually understand the normal. We're going to explore the incredible work of Dr. V.S. Ramachandran and his totally groundbreaking approach to decoding the human mind. Honestly, think of this like a neurological detective story, where the mysteries aren't your typical crimes, but the very functions of our own consciousness.
Okay, let's kick off this mystery by looking at some absolutely wild medical cases. Imagine patients who feel phantom arms that can literally grab an imaginary coffee cup, or a woman who actually died laughing. How about a nurse seeing Bugs Bunny in her blind spot? Or a young man convinced his parents are perfectly disguised imposters. Now, you might be wondering, what on earth do all these have in common? Well, the crucial point here is that these patients aren't crazy. Sending them to a psychiatrist, total waste of time. Instead, their brains have suffered highly specific damage, and that damage provides us with invaluable clues to a locked room mystery, how the normal human mind actually works. As the legendary neurologist Oliver Sacks points out in the foreword of our source material, Phantoms in the Brain, these seemingly freakish and irrational symptoms aren't just random madness. No way. They're actually completely normal defense mechanisms and rapid brain reorganizations that have just been pushed to absolute extremes. By understanding the abnormal, we can map out the architecture of the completely healthy, everyday brain.
Section 1. The Detective's Method: Tinkering and Talking Pigs. To solve these massive mysteries, you have to understand that neuroscience isn't about grand, overarching, unified theories just yet. We're currently in a highly experimental tinkering stage, where straightforward, sharp observation beats complex mathematical models every single time. And that brings us to what Dr. Ramachandran calls the talking pig analogy. You see, in medicine, there's a huge tension between folks who rely on massive statistical averages and those who study single, extraordinary cases. But think about it for a second. If I bring a pig into your living room and it starts talking, you wouldn't say, well, that's just one pig. Show me a massive statistical sample of talking pigs before I believe you, right? Just one single case, studied correctly, can revolutionize absolutely everything we know. The main takeaway? Simple observation is incredibly powerful. Just look at history. Galileo didn't invent the telescope. He literally just took a toy cardboard tube, pointed it at Jupiter, discovered its moons, and completely dethroned the idea that Earth was the center of the universe. Or fast forward to Dr. Bill Marshall. He noticed bacteria in ulcer cultures, and when nobody believed him that the bacteria caused the ulcers, what did he do? He went ahead and swallowed a beaker of the bacteria himself to prove it. A sharp, curious mind that's open to anomalies is, for sure, the ultimate scientific tool. Section 2. The Scene of the Crime: Mapping the Human Brain. Before we can solve the behavioral mysteries, we really need to understand the hardware we're working with. At the microscopic level, the brain's complexity is just staggering. A piece of your brain the size of a single grain of sand contains hundreds of thousands of neurons, all communicating via tiny connection points called synapses. Because of this massive web of connections, it's actually been calculated that there are more possible brain states, like more combinations of activity, than there are elementary particles in the known universe. That is mind-blowing. Zooming out from the microscopic, we see the macro structures. You've got two massive cerebral hemispheres connected by a thick band of fibers called the corpus callosum. You have the outer lobes, frontal, parietal, temporal, and occipital, handling everything from movement to vision. And if we look deeper inside, we find these older, more primitive structures. There's the basal ganglia, which handles our automatic habits, and the tiny, seahorse-shaped hippocampus, which manages our memories. Keep these structures in mind, guys, because they are the prime suspects in our neurological mysteries. Section 3. Modularity, Holism, and Baywatch: How the Brain is Organized. Now, this brings us to a massive 300-year-old debate in science. How is the brain actually organized? Are brain functions isolated in specific, separate modules? Like, is there a math module, a language module, a face recognition module? Or is the brain purely holistic, where functions are just spread evenly across the entire biological mass, with everything connected to everything else? To show why taking extreme sides in this debate is completely absurd, let's consider a rather ridiculous question. Where exactly is the TV show Baywatch localized? Obviously, the show isn't just sitting in one specific place, right? It's in the phosphor on your screen, it's the dancing electrons in the tube, the electromagnetic waves in the air, the celluloid film in the studio, the whole shebang. To say it's strictly in one place is wrong, but to say it's just everywhere is also completely useless. But here's the thing.
Looking closely at the cathode ray tube of a TV is going to tell you vastly more about how the broadcast works than looking at the chair you're sitting on. Meaning, searching for local modules in the brain is a really great place to start our detective work, even if the whole system ultimately works together. Section 4. Uncovering hidden circuits, solving the bizarre mysteries.
So let's apply this method of tracking down localized circuits to actual patients to uncover the hidden modules of human nature. This is where the detective work gets really incredible. Take the bizarre case evaluated by Dr. Kurt Goldstein over 50 years ago. A perfectly sane, middle-aged woman walked into his clinic with a terrifying complaint. Every now and then, her left hand would fly up to her throat and actively try to strangle her. Literally, she had to use her right hand to wrestle her left hand down. Other doctors completely dismissed this as mere hysteria or some psychological disturbance, but Goldstein solved it using pure neurological deduction. He figured out that a stroke had severely damaged her corpus callosum. Remember that critical bridge connecting the two halves of the brain? Because of that damage, the rational left hemisphere lost its connection to the more emotionally volatile right hemisphere. Without the left side's inhibitory brakes, the right brain's latent suicidal urges were suddenly unleashed, commanding the left hand to attack. A microscopic severing of a wire literally resulted in a murderous hand. And this brilliantly illustrates another hidden circuit, the smile. Seriously, try faking a smile in a mirror right now. You'll realize it looks kind of forced, tight, almost like a hideous grimace. That's because when you command a smile, your brain routes that request through the motor cortex, which handles complex, skilled movements. But a genuine, spontaneous smile, like when you unexpectedly see an old friend, that relies on a completely different hidden automatic circuit located deep in the basal ganglia. Two entirely different brain regions for what seems like the exact same action. How cool is that? Similarly, doctors uncovered the specific module for laying down new memories through a really tragic case known as patient HM. You might assume that the memory of a rose, its smell, its color, what it means, is spread across the whole brain. But to cure HM's severe epilepsy, surgeons removed a tiny structure called the hippocampus. And while HM kept his high intellect in all his old memories, he completely lost the ability to form a single new memory. If you left the room and came back a minute later, he'd have no idea who you were. The hippocampus was the crucial, localized gateway to the future. Ultimately, as we track these phantom circuits and talking pigs, this explainer reveals the peculiar, recursive quality of the human brain. Think about this for a second. It is the only massive matter in the known universe capable of looking over its own shoulder to question its very existence. If a tiny stroke can unleash a strangling hand, or a scalpel can erase the ability to make memories, if our minds arise exclusively from this biological machinery, what scope is there for free will? It's a mystery that leaves us not just with answers about the brain, but with profound questions about who we truly are.